Alright, in this video we take on the last part of the trigonometry unit, and we start by looking at a table of values being asked to identify some information about it. So the first thing, even though they don't ask us about it, I want to start by identifying what is the maximum and what is the minimum of this function. And if I look at the y coordinates, because that's going to be the vertical position of the function, the maximum value I ever see is 50, and the minimum value I ever see is 10. And we have to remember that trigonometric functions oscillate like this, between a maximum, in our case, of 50, and a minimum, this is not drawn to scale, of 10. That shouldn't be below the x-axis. But they're oscillating between two values, and in our case they are 50 and 10. And to me that's really helpful because I know that the midline is going to be exactly between those values. So I can either just sort of guess and check what's exactly in between them. Even easier to me is to average the maximum and the minimum. So if I average 50 and 10, just add them up and divide by 2, I get 30. And that's the equation of the midline, y equals 30. And we write it as an equation. Let me draw this a little bit more to scale. We write it as an equation of a line because that's an imaginary line about which the graph oscillates. So I have 10, I have 50. My function starts here and comes down and up and down and up. And so what I just identified was this midline. It's this imaginary line in here, and that equation of the line is y equals 30. Okay, so that comes from being exactly in between the maximum and the minimum. The amplitude then is how far the graph oscillates above that midline and how far it oscillates below the midline. So how far from the midline does the graph go up to get to its maximum? Well, from 30 to 50 is 20 units. From the midline, how far does it go down below the midline? And that's also 20 units. That's our amplitude. Okay? So that's where those two numbers come from. And then there's the period. The period is the duration on the x coordinates that the function takes to complete one cycle. Because this obviously has a cycle where it goes down and comes back up and goes down and comes back up. So to complete one cycle, it needs to do that whole process of going down and coming back up to its maximum. So I'm looking for, it started at a y coordinate of 50. When does it get back to a y coordinate of 50? And that's right here. So along the x-axis, how far is that? And that takes 8 units, from 0 to 8, and so our period is 8. Okay? Moving on to a similar problem, we see the function starting at 18, going down, coming back up to 18, going down, coming back up to 18. So I'm going to again start by identifying what is the maximum, what is the minimum. These are questions that I think are really good to ask and answer. My maximum value is 18. My minimum value that I see is 2. So to find the midline, I'm going to average these two values, 18 plus 2 divided by 2, just the average, what's right in between them, and that comes out to be 10. So the equation, notice when they ask for an equation there has to be an equal sign, so it is y equals 10. It's a horizontal line, y equals 10. Now, the amplitude is how far the graph oscillates above that midline and how far it oscillates below. So from the midline to the maximum is 8 units, from the midline to the minimum is 8 units, and so the amplitude is 8. Okay? And the period is along the x-axis. How far is it to complete one cycle? Well, I notice this is one cycle, from 18 back to 18 on the y coordinates. That's from the max, down and back up. So my period is pi over 2. All right? And we move into some applications here. We have a pony ride, and you're going in a circle on the pony, and here is the fence. Okay, and so you start on the pony and you're going around this circle. They're saying the radius of that circular path is 15 feet. The distance from the fence to the center of the circle is 20 feet, so that tells me that this distance must be 5 feet. And the pony is going to complete one counterclockwise rotation every 36 seconds. So we're going to start here at position S, and Pauline is going to start timing there. And at all these different angles, she wants to know how far Pauline is from the fence. So I'm going to draw a picture to help me figure this out. But for the 40 degrees, I have the circle, the fence. When Pauline has gone 40 degrees from here, this is where my angle is starting, 40 degrees is about like that, okay, where this is a 40-degree angle. Now, I want to know how far Pauline is from the fence. Well, I'm going to start by figuring out that distance that I just drew in a dotted segment. I'm going to draw that distance first, or I'm going to figure out that distance. And I can figure out that distance using right triangle trigonometry. Okay? I know that this distance here is 15 feet because that's a radius of the circle. And so I have 40 degrees. I want to know the side opposite the 40 degrees, and I know this radius. So that calls for sine. The sine of an angle is the ratio of the opposite side to the hypotenuse, or, as we talked about before, the y-coordinate to the radius. Okay? And so again, you want to make sure that your calculator is in degree mode, and you are going to type in the sine of 40 degrees, and you get something like 0.6427876. Okay? But in order to solve for that question mark, I'm going to multiply both sides by 15. And so without doing anything, I'm just going to hit the times button on my graphing calculator and then 15. And that will make it so that I haven't rounded my answer at all. So that question mark then is 9.6418, about. Okay? So that's that distance, but that's not the question they asked me. They said, how far is she from the fence? Well, that also involves this distance, which if I look back at the original picture is the same as this distance. So this is 20 feet, and I want to go ahead and add that on to the 9.6418. And I get 29.6418. But if you read the directions, it says round your answers to the nearest tenth of a foot. So I want to round to this place. So I look at the place right after it. It's a 4, which means round down, meaning we're going to leave our answer at 9.6 feet. Okay? At 117 degrees, I'm going to try to more quickly draw this. So here's my starting point. I know that straight up is 90 degrees, so this is kind of going to be like so. This is 117 degrees. And I'm going to set it up the same way. If I kind of shortcut this a little bit, I can see that I could do sine of 117 equals, and this time I'm looking for this angle. I'm sorry, this side length right here. Okay, sine of 117 equals that question mark over 15. So I'm going to say that question mark distance is 15 times the sine of 117 degrees. Okay, that's just the question mark distance, which I can enter all into my calculator at the same time, and that comes out to be 13.365. But then I need to go all the way to the fence, so the rest of that distance, like before, was 20 feet. So I'm going to add 20 feet and get 33.4 feet. It's actually 33.36, but because that 6 is larger than a 5, I round up to 33.4. Okay? One more time with 230 degrees. Here's my starting position. 230, well, straight across would be 180. Here's 270, so I'm going to be somewhere about like that, where this angle here is 230. And so this distance is actually, if you think about it, from here to the ground, or here to the fence, I'm sorry, is 20 feet. This should actually come out to be less than 20 feet when I'm done. So I'm going to think, what is this distance? And so my question mark distance here is 15 sine of 230. And I get negative 11.49. Why does it make sense that it's a negative number here? Yeah, because it is down below the starting position. So I'm going to add 20 to it, just like I have every other problem. And so I get that the distance from the fence, which ultimately is just this distance, is 8.5 feet. Okay? So I started by finding just the distance to the midline, to that, to this position, the distance to here. I started by finding that. I called that the question mark distance. And then I added 20 because that was constant, the distance from that midline to the fence. Okay? And now we take this just one more step and we say, okay, what if I'm given times instead of angles? Well, I only ever take the sine of an angle. So when I need to consider times instead of angles, I need to somehow convert the times into angles. Okay? So let's think about this. If a counterclockwise rotation occurs every 36 seconds, that means that Pauline is going 360 degrees every 36 seconds. So if I think about that a little further, that means she's going 10 degrees every second. Okay, and I got that by dividing 360 by 36. So she must be going 10 degrees every second in order to complete 360 degrees in 36 seconds. So instead of reading this as 1 second, we know that in 1 second she's gone 10 degrees. And this becomes a similar problem to what we had before. So I'm going to do 15 sine of 10 degrees, and then I'm going to add 20 to it. And do you remember from the last slide why we add 20 to it? Yeah, it's because that's the distance from S to the fence. So when she's gone 10 degrees, which is a little baby angle like that, that's in 1 second. When she's gone 10 degrees there, we can figure out this distance, and then I add 20 to it. So this becomes just enter it into your calculator, make sure you're in degree mode. And I got 22.6, again, round to the nearest tenth of a foot. So I got 22.6 feet. Okay? For 24 seconds, well, that gets a little bit more complicated. It's not as easy just to know how many degrees. So how about we do this? We can say 15 sine, except instead of just writing a number of degrees right off the bat, let's think about it this way. Let's say she goes 10 degrees every second times 24 seconds. Maybe you can do that mental math, but 10 degrees per second for 24 seconds means that she's gone 240 degrees around the circle. So 15 sine of 240 degrees this time plus 20 gives me 7.0 feet. Okay? And even though it's a 0, when I'm rounding to the nearest tenth of a foot, I do show the 0. Let's see if that makes any sense. If she's gone 240 degrees, that is something like here. Does that make sense that she is only 7 feet away? Sure it does, because we remember down here she was 5 feet away from the fence. So that makes sense that she's a little bit further than 5 feet from the fence. Okay, one more. We're going to do 15 sine, and we're saying to ourselves she's going 10 degrees per second for 31 seconds. And, oops, not add 21, add 20 to it. So 15 sine of 310 degrees this time, plus 20, and this time it is 8.5 feet from the fence. Okay? Sketch a graph to represent this distance. Okay, well, at time 0, she is exactly 20 feet from the fence. And let's fast forward all the way around one pony ride. After 36 seconds, she is again exactly 20 feet from the fence. Are there any other times that she's exactly 20 feet from the fence? Yeah, when she is halfway through the pony ride, she's that same 20 feet from the fence. So that is at 18 seconds. She's 20 feet from the fence. Okay, that's going to be our midline that we talked about before. And then when she is the absolute furthest from the fence, she's the absolute furthest from the fence when she's here. And how far is that from the fence? Well, that is these 20 feet plus another radius is 35 feet, which it's a little hard to see on this grid, but I believe that's here. Oops, I didn't mean to do that. And that is going to be at 9 seconds, okay, right between when she is at these 20 feet from the fence marks. Okay, and then I want to say, when is she absolutely closest to the fence? She's absolutely closest to the fence when she is down here. Let me actually erase some of this. She is closest to the fence down here, and we've said this before, she's only 5 feet from the fence there, and that's going to be right between the 18 seconds and the 36 seconds. So that looks like it goes about here. Okay, and that should give us enough to draw this trig function. Okay, and if I wanted to draw in the midline, I would draw it in like this. And the equation of that midline is y equals 20. We oscillate further from the fence than that and closer to the fence. Okay, the amplitude is how far above and below that midline do we oscillate? Well, we go from 20 up to 35, and we go from 20 down to 5. So in each of those cases, it's 15 units. The period is how long does it take to do one complete cycle? Well, in this case, we start at the midline and go up and come back to the midline and go down and come back to the midline. That's one full period before you would start, if you stayed on the pony, going up again. So that period is 36 seconds in this case. And the equation of the midline, I wrote it over there, is y equals 20. Okay? So when I write the equation, this is a sine function because it starts at its midline. So I'm going to start by writing y equals sine. Okay? This amplitude is a vertical dilation So I'm going to put a 15 out in front of it so that all of the y coordinates are multiplied by 15 to become 15 times as large. The period, let me actually come back to that part. I think that's the hardest. The midline here is a vertical translation, so I add 20 to it. Okay. Now, inside those parentheses, I need my variable x, or my variable t, I guess I should call it. And let me actually use the variables that they've given me, which is d. Okay, so I definitely need a t in here, but I want to think, what did I do in each of these cases up here? What did I do to turn them into angles? Okay, because just putting a time in there did not give me an angle. I needed to say, okay, after this amount of time, she had gone this many degrees around the circle. What did I do in each of those cases? Well, I took the 10 degrees per second and I multiplied it by the amount of time. So this number came from the 360 degrees every 36 seconds, but this is the number of degrees per second. And then I multiply that by, obviously, the number of seconds. And multiplying a number of degrees, I go per second times the number of seconds gives me a number of degrees that I've rotated. Okay? And there we go. That is the end of our trig. So I hope this has been helpful. Good luck in your studying.